DeepSeek just dropped a bombshell. Its upcoming model claims to close the performance gap with the frontier titans like GPT-4. Imagine a challenger that can match the best, but at a fraction of the cost. Stick around, because we're about to put that claim to the test, side by side, in real time. First up, we feed both models the same complex prompt: write a short story blending quantum physics with noir detective tropes. Watch the screen split in half, on the left, DeepSeek, on the right, GPT-4. Notice the pace, coherence, and creativity as the words appear almost simultaneously. Next, we push the limits with a math-heavy request: solve a multivariable calculus problem and explain each step in plain English. The clock ticks, and both models generate step-by-step solutions. Pay close attention to accuracy, notation, and the clarity of explanations. So, does DeepSeek really close the gap? The numbers speak louder than any tagline. We'll break down latency, token cost, and performance metrics in a rapid-fire graphic, then let you decide if the claim holds water. Stay tuned, proof is just a click away. DeepSeek has unveiled its next-gen model, dubbed DeepSeek V2. The company says it runs on a 1.2 trillion parameter transformer, roughly double the size of its previous release. Trained on an eclectic mix of public web text, scientific papers, and multilingual code repositories, V2 aims to bridge the gap with the current frontier models. Expect the public rollout by early Q4 2024, with an API beta opening next month. Let's peek under the hood. V2 stacks 96 layers of attention heads, each with 128-dimensional embeddings, arranged in a classic encoder-decoder layout. Compared to DeepSeek V1's 600B parameters and 48 layers, the new architecture adds depth and width, boosting context windows up to 16,384 tokens while keeping inference latency under 30 milliseconds per token on a 100 GPUs. Where does the data come from? DeepSeek sourced 5 petabytes of text, pulling 70% from curated web crawls, 20% from peer-reviewed journals, and 10% from multilingual code bases. They applied a two-stage filtering pipeline: first, deduplication and toxicity removal; second, linguistic quality scoring, to ensure clean, high-value inputs for training. Timing is everything. DeepSeek announced V2 in mid-May, released a technical preview in early July, and plans a full public launch by the end of October. The staged rollout gives developers early access to the API, while the company gathers real-world feedback to fine-tune safety filters before the final release. First, let's decode the MMLU benchmark: medical, law, and university exams rolled into one. DeepSeek V2 scores a 78.4% accuracy, just shy of GPT-4's 79.1% and nudging past Claude 3's 76.7%. Gemini trails at 75.9%. This metric tests raw knowledge across 57 subjects, so the gap is practically closed. Next up, GSM-8K, the gold standard for grade school math reasoning. DeepSeek V2 hits 92.3% correct, edging out GPT-4's 91.8% and matching Claude 3's 92.1%, while Gemini lags at 88.5%. The task forces models to solve multi-step word problems without shortcuts, highlighting DeepSeek's improved chain-of-thought capabilities. For code generation we turn to human eval. DeepSeek V2 generates correct solutions for 66.5% of the 164 Python problems, outpacing GPT-4's 64.9% and Claude 3's 65.2%, while Gemini sits at 61.4%. This reflects the model's newer multilingual code corpus and enhanced syntax awareness. Lastly, we look at latency and cost. On an A100, DeepSeek V2 processes 1,000 tokens in 28 milliseconds, matching GPT-4's 27 milliseconds and beating Claude 3's 35 milliseconds. Token pricing is $0.0012 for DeepSeek versus $0.0015 for GPT-4, giving a 20% cost advantage while delivering comparable scores across the board. DeepSeek's leap starts with a hybrid data pipeline. First, they pre-filter 5 pb of raw text using a fast bloom filter, then run a second-stage quality net that scores linguistic richness and factual density. The clean 2.3 pb mix blends 70% web, 20% peer-reviewed papers, and 10% multilingual code, delivering a higher signal-to-noise ratio than traditional crawls. Training leverages a two-phase schedule. Phase 1 uses mixed precision FP16 with a dynamic loss scale, cutting memory by 40% while keeping convergence stable. Phase 2 switches to float 16 for the final 15% of epochs, exploiting its wider exponent range for better gradient fidelity. The result is a 1.2 trillion parameter model trained in just 28 days on a 512 GPU cluster. Architecturally, DeepSeek introduced sparse mixture of experts, SMOE, within every fourth transformer block. Each block activates only 2 of 8 experts per token, reducing flops by 30% without hurting expressiveness. They also swapped the vanilla softmax for a flash attention 2 kernel, having attention latency for the expanded 16K context window. Inference speed comes from a combination of kernel fusion and quant-aware distillation. DeepSeek compiles the transformer into a single CUDA graph, eliminating kernel launch overhead, and applies 4-bit weight quantization while preserving 99.8% of FP16 accuracy. The net effect, sub-30 ms per token on a single A100, matching frontier models at a fraction of the compute cost. For developers, DeepSeek v2 translates into a tangible cost shift. At $0.0012 per 1K tokens, the model is about 20% cheaper than GPT-4, while delivering comparable benchmark scores. That reduction lowers the barrier for startups and research labs to run large-scale prompting or fine-tuning without blowing their cloud budget, opening up experimentation that was previously reserved for big players. The competitive landscape sharpens. OpenAI now feels pressure to defend its premium pricing, while Anthropic and Google must accelerate their own model releases or bundle extra safety features to stay relevant. Expect a flurry of announcements, price adjustments, and perhaps more open-source collaborations as the market strives to retain edge in a narrowing performance gap. Model release strategies are likely to evolve. We could see shorter iteration cycles, with companies unveiling preview APIs months ahead of full launches, mirroring DeepSeek's beta approach. This agility lets developers test early, provide feedback, and lock in pricing, while vendors collect real-world data to fine-tune safety and performance before the final rollout. In short, DeepSeek's v2 compresses the gap between frontier and accessible AI. Cheaper, high-performing models democratize innovation, force incumbents to adapt, and reshape how new models hit the market. Stay ahead of these trends by subscribing now, your go-to source for fresh AI analysis, benchmarks, and insider perspectives.